Hello everyone, welcome back to physics class. In today's class, we'll do revision of chapter 9, force and laws of motion. Now these are the main points that we are going to cover today. What is force? So when you talk about force, the definition, the simplest definition that comes in our mind is push and pull. But this force, this physical quantity is more than that. And in this chapter, we are going to explore what actually force is. We'll see its definition, its expression, and how vast its definition is. So, as of starting, what is force? It is simply when you push anything, when you pull anything, what you apply is force. Now, when you apply force, what are the effects that you can see force? So, let's say if I had an object over here, a bench. If I push that bench, what effect you are going to observe? That bench is going to move. Or let's say a fast coming ball. What will happen if I apply force in the opposite direction of motion of that ball? That ball is going to stop. Then when I stretch rubber band, okay, here also I am applying force. So what is happening? This change in shape of that rubber band, right? And similarly, if I compress, let's say sponge, what will happen? This change in shape of the sponge, though it is compression. So when you talk about effect of force, you can say when we apply force, an object, it may make object come in motion, or it can stop the object, it can change shape of the object, shape and size, whether it can elongate it or compress it. It can change direction also, so there is change in direction. So these are the main effects of force. Now types of force. If you have studied in class 8, mainly in class 8 you have divided force into two types, contact forces and non-contact forces. So if you remember, what are contact forces? If an object is in contact with the source of force and then force is applied. Okay, like when a ball is coming, when you try to stop it, you are in contact with ball. At that time, you are applying your muscular energy to stop that ball. So this is contact force, when an object and source of forces are in contact with each other. So contact force, example, one is frictional force, which is between me and the surface, when you are writing in a notebook, between tip and the notebook. Now non-contact forces. What are non-contact forces? When the object and source, they are not in contact with each other. Okay. A very simple example is gravitational force, magnetic force, electrostatic force. So these forces need not to be in contact with object. Like in electrostatic force, when you rub a comb on your dry hair and bits of paper, they stick on that comb without touching those bits of paper. This is non-contact force. This effect, this field of force that is attracting those bits of paper. Similarly, magnet. When you use magnet, a pin, an iron nail, it can attract from a distance. That is non-contact force. Gravitation, if I drop this object, it's not going to float. It will go down because of gravitational attraction, and it is not in contact with gravity. Though it goes down because of non-contact force effect, strength of force. Now force you cannot see. Okay, it is a quantity that you cannot see. You can only feel it. You can see its effect. You can feel its presence, but you cannot see it. Now here, so there are, other than contact and non-contact forces, there are many other type of forces, okay, present in the nature. Restoring force. Then here, in this chapter, we are going to divide force in two types. Balanced and unbalanced force. Now what are balanced forces? Let's say you have an object, this duster in hand, and the various forces acting on this object. One I am applying on this direction, some force. Now because it is in contact with my hand, so there is frictional force between this surface and hand, so there is frictional force. There is gravitational force in the downward direction, and this force, there are many forces acting on this object. If this object is like this, and I am applying forces and still it is not moving. What does it mean? All forces here are balanced. So this object is not at all moving. So when all the net force on an object is 0, what you have is balanced force. So all forces, there are different forces acting on this object, they balance each other, and the net total of this forces is 0. Now, same duster, if I apply force, and if you see it is moving in some direction, it is changing, there is some movement of this object. In this case, we can say application of force is changing position of this object. So now, what you have is unbalanced force. Okay, again please say it. So if you have duster on my hand, like this, if I am applying force in this direction, it is moving. Okay, so there is some net force because of which it is moving. These forces are not balanced. So in this case, it has some unbalanced force because of which it is moving. And these two very simple examples lead to a very important conclusion. That is, whenever you have unbalanced force acting on an object, that object is going to change either its position, motion, direction, but there is going to be some change in that object's motion. So if, let's say this object is already moving, and if I apply force in this direction, then we will stop this object. So effect of unbalanced force is to change direction, motion, or to stop the object. But if there is balanced force, this object is not going to move anywhere. It will remain in its position. Okay. And balanced or unbalanced forces is sum of all forces acting on this object. It is not like that we will talk only about this force and this two-direction force. No. You have to take in consideration all direction forces, then you have to see whether forces on this object is balanced or unbalanced. So let's say this is an object A. If I am applying force of 5 Newton in this direction, 10 Newton in this direction. So this is the condition of, if you see 5 Newton, 10 Newton, unbalanced force. 5 Newton in this, 10 Newton in this. So net force is 10 Newton and it will displace this object in this direction. If in case, if I apply like this, if I do like this, then in this case, object will move in this direction with total force of 15 Newton. Okay, you may have condition like this also. Let's say 2 Newton and 4 Newton, and this is in opposite direction. This is 5 Newton. Now, so you have to see these two forces, and see whether the pair they are cancelled out or not. If not, that means force is unbalanced and this object is going to change its position. That's all for today. In the next class, we'll move to first law of motion, Newton's first law of motion, little bit history and then first law of motion. Thank you.